calculations. We have done some FLSM calculations with A class, B class, C class examples by using some of the examples using a step-by-step method. And also we have seen some basic how to identify the slash value and what is the importance of slash value. It actually represents total network bits, and then subnet mask. So we are done with FLSM because FLSM is something which is very basic thing, fixed length subnet mask, where we are dividing all the networks into equal sizes. But it comes to requirements. So in this session we are going to see about VLSM. We are going to see some of the VLSM calculations, variable length subnet mask calculations by using A class, B class, C class, and also we are getting into some more advanced subnetting. Mostly this is the last video for advanced subnetting, where I am going to discuss some of the shortcut methods which can be very useful, especially when you are solving the bits. And also we'll see finally some subnetting questions, like the questions how you will be tested in your certification exams, or it can be in your real scenarios. Very useful to finding and solving some of the subnetting questions. We'll take some examples on that and we'll probably focus on that. So you're done with FLSM. So first we are going to start with something called VLSM first. Okay, so let us start with VLSM. So already we know that there are two methods of doing subnetting. The first one is FLSM and the second one is VLSM. So FLSM divides the networks into equal sizes. Let's take an example in my company. Like the first example, in my company I got some department: accounts, marketing, I got sales department, and I got HR department. And every department have a variable requirement. Let's say the first department, accounts, is having a requirement of 100 hosts. So it is having a requirement of 100 hosts. Maybe marketing department just I have 50 users, 50 hosts, and the sales department I just have only 20 users or 20 hosts. And finally HR department I just got only a requirement of 4, maybe 4, or I can say 6. So whatever the size of the network. So my requirement is varying, where if you take the first network is 100 size, and the second network is just 50, third network is 20, and the fourth network is just 6 addresses. In most cases, in most of the scenarios, we have a variable size requirements, like the requirement can vary as per the requirement. So up to now we did something called without subnetting. If I just go without subnetting, so I'm going to use the smallest possible size C class. I'm going to use 192.168.1 dot network here, 192.168.2 dot network, 192.168.3 dot network, and 4 dot network. So each and every department I'm going to use a separate C class network. So which means I'm going to use, out of 256, I'm going to use only 100 hosts. So definitely I'm going to waste more than 156 addresses, or simply wasted. Similar way in this scenario, again the same thing. Out of 256 I'm just using only 50. So without subnetting. So if I just don't go with subnetting, but we have a better solution than that. So what I can do is I can do FLSM, and I can divide this network into nearest possible sizes. 2 to the power of 7, 128 is the nearest possible size. So using FLSM I can divide all the networks into 128, 128, 128, 128. So this is what FLSM, where we need around 512 plus addresses required to meet the requirement if I want to make all the 4 departments in different networks. So but the problem with FLSM is much better than default networks. So if I use default networks, I got more wastage, because out of 256 I'm just using 100, or I'm using just 50, or I'm just using 20 addresses. So the first thing will go with default networks in case if there is no subnetting. So which I don't recommend. Default network sizes we are not going to use. The second option we have is FLSM, where I can divide all the networks in equal sizes. So but even if you do FLSM, if you just take the example, this one I got a 6 requirement, and for only 6 addresses, going for 128 size is something which is not recommended. So using VLSM, what I can do is I can divide nearest value. Nearest value means I can just say, using VLSM, so the requirement is 100, so I'm going to go with 128 is the nearest possible size if you consider 2 power value. And for 50 users I'm going to divide it with 64 size. For 20 users, nearest possible size is 2 to the power of 5, 32. And for 6 users, the nearest possible size is 8. So if you remember, 2 power 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 power 6 64, 2 power 7 128. So I'm going to use this size for the first network, and I'm going to use for 50 users, I'm going to use this network, and for 20 users the possible size is this, and for 6 users the possible size is this. So this is what VLSM. So this is the basic difference between FLSM and VLSM. In FLSM we are dividing the networks, and all the networks will be equal sizes, and it is very rare you will find all the networks with the equal requirement. You may not have same requirement, so the requirement can vary depending upon the departments, depending upon the organization requirements. So based on that we can divide in variable sizes. So this is separate size, this is separate, this is separate, and this is separate. Maybe same, may not be same. Just like when we have a kitchen, bathroom, hall, bedroom, it's very all are variable sizes as per the requirement. So the same thing we are going to do here. So if we just compare FLSM and VLSM, if I do FLSM I need 500 addresses, but using VLSM I can just minimize my requirement to just around 200 plus addresses. So using VLSM we can further save a lot of IPs when we compare with FLSM, because FLSM is something everyone have the same requirement, which is very less common. But again, still the foundation is FLSM. If you are comfortable with FLSM calculations, we can say almost you are 80% clear with VLSM calculations also, because most of the calculations goes the same. Okay, so this is just an overview of VLSM. Let us see some example. The same example I'm going to take, the same example requirement I'm going to take: accounts department 100 host, marketing department let's say 50 users, and sales department I just have 20 users, and HR department I got 6 users. These are my requirements: one for the accounts, one for marketing, one for sales, and other for HR. So I want to divide a network. First start with C class, because if I take C class, that is enough as my question. So C class by default supports 256 addresses. I don't want 256, I want to divide my networks into variable sizes as per the requirement. So let's start with this requirement. So better we start with the highest number. So I'm going to take the highest number as 100. So I'm going to take 2 to the power of h minus 2 greater than equal to requirement, and my requirement is 100. So as per 2 power table, so the nearest value satisfies my condition is, you can see here I got a 2 power value, 2 power 7 satisfies my condition. So I'm going to take 2 to the power of 7 value, which is going to satisfy my condition. So 2 to the power of 7 becomes 128. In that 128 addresses, 2 addresses we cannot use, because network ID in the broadcast ID, which means total 126 is your valid host address. It means in future if you want to add extra devices, you can connect maximum of 126 devices. The next thing from this, whatever the power value you get, that is your required host bits, is 7. And right now I'm working on C class. So in C class by default there are 3 network portions. You know that there are 3 network portions and 1 host portion: 1 2 3 4 5 6 7 8, which means there are 24 network bits and 8 host bits. Out of 8 I just need only 7, so I'm going to convert 1 bit into network. So 7 as it is, the host bits are 7 as it is, and 1 gets converted. So the tally changes to 8 plus 8 plus 8 plus 1. In the previous session we have seen these conversions. So total becomes what, /25. I'm minimizing some of the steps because you are a little bit much comfortable. In the previous videos we have seen some step-by-step calculations for all these things. Now if you add 8 bits it becomes 255, 8 bits if you add 255, 8 bits if you add 255, and 1 bit if you add 128. So this will be our subnet mask. So up to here you can see the entire calculation remains the same, no changes. Till this point the entire calculation remains the same. Now the only difference is when we write the range. Writing the range varies. So the range always written based on 2 to the power of h value, and in our case if I just consider any network, let's say I'm going to use any C class 192.168.1 network. So let me use another network like 200.1.1 network. So whatever, any C class, the calculation remains the same. So the first 3 portions are going to remain the same: 200.1.1 and 200.1.1. Similar over here, 200.1.1 200.1.1, 200.1.1. Okay, so now the first requirement is, the first size of the network is 2 to the power of h value is how much? 2 to the power of 7, and it is 128 is the size of the network. So 128 means the network starts on 0 and the next network starts on 128, which means 0 to 127 becomes one network. Okay, why? Because the group of addresses, 128 addresses group becomes one network. So 0 to 127 becomes one network. So I'm going to use plus, just I'll write plus here just for understanding how many group of addresses I grouped, how many addresses I grouped here. And finally the slash value will be, what will be the slash value? The slash value will be 25, because if you remember just now we did the calculation in our example. If you see here what I got, the slash value represent total network bits, nothing but it is another way of writing your subnet mask. Either you have to define the subnet mask in 255, 255, 255, 128 format, or you have to define in the form of slash value. Okay, so this is my first range. So this is my first network which I got as per my network. So as per my requirement, so my network starts on 0 here. So this is my first network, I can say. This is my first network. Okay, so this is my first network, and the size of that network is 128. So now the next network starts from 128, because I already given 0 to 127 for some department called accounts. So next network starts from 128, and the next size, I'm not sure exactly what will be the next size. The next size depends upon the next requirement. So let us come to our second requirement. As per the question, the second requirement is 50 addresses. So let's take the second example. The requirement is 2 to the power of h minus 2 greater than or equal to requirement, and the requirement is 50 here. So as per this requirement, 2 to the power of 6 value satisfies my condition, because 2 to the power of 5 is 32, 2 to the power of 6 becomes 64. 64 minus 2, that is equal to greater than or equal to 50. So 62 is your valid host address, means I can connect maximum 62 host addresses, and from these host bits I got 6 host bits, required host bits. So I'm discussing C class. So C class contains 3 network portions and 1 host portion, nothing but 8 bits. Out of 8 bits I just need only 6, so only 6 are required. So remaining 2 I'm going to convert them into network. So it will become 8 plus 8 plus 8 plus 2. So total network bits becomes 26, and the subnet mask will be 255, 255, 255, 192 will be the subnet mask. So this is my slash value. So if we just try to see here, this example, this calculation is exactly the same what we did in our FLSM. The only difference comes, I just minimize some of the steps in our previous examples when compared, and the next network size is 2 to the power of 6. 64 is the size of the next network, which means I have to add plus 64 addresses, means 128. From 128 group of 64 addresses becomes one network. So which means 128 plus 64, it becomes 192, which means 191. So slash value will be 26. So slash value will be 26 because there are 26 network bits. If I write slash value 26, it represents exactly 6 host bits. So the size of the network will be 2 to the power of 6. So this is my second network, and the size of my second network is just 64 addresses. If you just try to see here, this is group of 128 addresses, this is group of 64 addresses. Now they are totally different networks. Similar way, if I just go on with, now 0 to 127 is given to accounts department, and 128 to 191 group of 64 addresses given to marketing department. So now in the same existing C class, I have available addresses from 192. So I'm going to take the third requirement. Now my third requirement is 2 to the power of h minus 2 greater than or equal to requirement. So third requirement, as per our example, we are done with 100, 50 is done. Now the third requirement is just 20 addresses. Same calculation we need to do. 2 to the power of 5 minus 2, because 20 means the nearest number satisfies 32. In the 2 addresses we cannot use. So 30 is your valid host addresses. So from here I can realize I can just find out that host bits required is 5. So C class by default supports 3 network portions and 1 host portion. So host portion I'm just writing 8 zeros. Out of 8 I just need only 5, so remaining 3 gets converted, so it becomes 8 plus 8 plus 8 plus 3. So total bits becomes 27. So subnet mask will be 255, 255, 255, 224. So this calculation is same as what we did in FLSM, but the only difference again we are going to write the range. In the range, the C class range, that is starting from 0 to 255, is divided into 2 parts already. One part is from 0 to 127 is one network, group of 128 addresses, and 128 to 191 group of 64 addresses is another network given to another department or another branch office. So now we have addresses available from 192. So from 192 I just need only group of 32 addresses, because the next requirement to the power of 5, 32 is the next requirement. So next requirement is just 20 addresses, but as per my requirement I don't get exact number of 20, so I get 32 is the possible size of the network. So if I write group of 32 addresses plus 32, it will be 224 will be the next range. So it ends on 223. So from 192 to 223, a group of 32 addresses, and the slash value as per our calculation is /27, which represents 27 network bits and remaining 5 host bits. Based on that, the size will be decided. So this is your third network. So the first network is the 128 size, starting from 0 ending on 127, and the second network starts group of 64 addresses starting from 128 to 191 with a subnet mask of /26, and the third network starting from 192 to 223 group of 32 addresses, and it is given to the next department, maybe we can say sales department. And still we have other requirement left. So for the fourth requirement, again we need to do with the same calculation. The fourth requirement is just 6 addresses. I think it's 6, right, as per our question. As per our requirement it's 6. So I'm going to take 2 to the power of h minus 2 greater than or equal to requirement is 6. 2 to the power of 3 I can take, because 2 to the power of 3 becomes 8. 8 minus 2, so 6 is greater than or equal to 6. So from here I can see host bits are 3, and by default C class contains 3 network portions and 1 host portion, and I just need only 3 host bits, so remaining 5 gets converted, so it becomes 8 plus 8 plus 8 plus 5 /29, and the subnet mask will be 255.255.255.248. 5 bits if you add, it becomes 248. So all these things we did in the same calculation in the previous classes, so that's the reason I'm just minimizing some steps in these calculations, and also I'm just moving a little bit faster here because you are much comfortable with the calculations here. Now writing the range, the next range we are going to write only 2 to the power of 8, 2 to the power of 3, that is the size of group of 8 addresses. So plus 8 becomes 232. My range ends on 231, and the slash value is 29. So from 224 to 231, this is separate network. So now here you can see, if I just summarize this range, so I used the first network requirement. First question was, if I just summarize this calculation here, totally we got a requirement of, this is our requirement which I got in my question. The first requirement is 100 hosts, and the second requirement we got 50 hosts, and the third requirement is 20, and the fourth requirement is 6. As we cannot exactly get 100 size, the possible size is 128. This is what we did, 2 to the power of h value, and the next possible size is 64, and the next possible size is 32, and the next possible size is 8. So based on this, we have given 0 to 127 given for first department, and from 128 to 191, that is group of 64 addresses, given to the next department, and then 192 to 224 group of 32 addresses given to third department, and from 224 to 231 group of 8 addresses we have given to the fourth department. Still we have addresses available from 232 till 255, so we can use these addresses for any other future requirements. So this is actually the process, a calculation whenever we are doing VLSM. This is one basic method of doing the calculation. So here this example will give some very basic idea on how the subnetting calculation goes. But anyway, you have to this step-by-step method, whatever I discussed, all methods here. So it's good to have a better idea on this method. But once you are much comfortable with this step-by-step method, the next method I'll also discuss one more method, which is I consider as a shortcut method, which you have to follow in general once you are much comfortable with all these calculations. So it's nothing but a shortcut method of doing all these things. Okay, so no one is going to ask you to do all these calculations, but all these calculations, as an administrator, as an engineer, you should have a clear idea how many bits gets converted, what is the range, what will be the subnet mask, how many valid addresses, where it starts, where it ends. So that is something which is very important, and this step-by-step method calculations will give you a good foundations for your submitting calculations. So it is a little bit lengthier, but it gives a very good foundation for your calculations here. Okay, so now the next thing, so just make sure that you just practice this example, and once you practice enough, so now the next thing what I'm going to do is I'm going to use the same method, same requirement, but this time I'm not going to use a step-by-step method. The same question, the question remains the same. The requirement is 100 host,